Assalamualaikum, welcome viewers. Today inshallah we're going to start lesson 2, which is talking about the general properties of the first transition series. The first property we're going to talk about is the mass number, second is atomic radius, third is the metallic properties, fourth is magnetic property, five is colored ions, and the last one is catalytic activity. Let's start with the first one, which is the mass number. As the atomic masses in the first transition series increases gradually by increasing the atomic number, but we have an exception for nickel element. Nickel element is abnormal. This is due to the presence of 5 nickel isotopes with an average mass 58.7 atomic mass unit. The atomic radius. The decrease in the atomic size of the element of first transition element is not so large. The atomic radius is nearly constant from chromium to copper. This is due to the two opposite reasons. The first one is the increase in both the effective nuclear charge and the total number of new electrons by increasing the atomic number. That causes an increase in nuclear attraction of the electron, resulting in decreasing the atomic radius. This is the first factor. The second factor is increasing the number of electrons of 3D sublevel, which increases the repulsive force between them. This leads to the increase in the atomic size. And this is a give reason question, using the first transition series element in making alloys due to the relative constancy of their atomic radii. After that, the metallic property. And it appeared clearly that in the first transition series, all of these elements are metal, having a metallic luster, good conductors of heat and electricity. They have high melting and boiling point. That's because of the strong metallic bond in these elements, which existed due to the large numbers of electrons forming this bond as a result of the participation of electron of 4s and 3d sublevels in the formation of this bond. The elements of first transition elements have high density. They have high density of the first transition element series by increasing the atomic numbers because they increase in atomic mass while the volume is relatively constant. The variation of these chemical activities. There is a variation in the chemical activity of first transition element series. Scandium is highly active and it replaces hydrogen and water vigorously. Iron has a moderate activity, it goes rusty on exposure to the humid air. Copper has a limited activity. What about the magnetic property? The comprehensive study of the magnetic properties has an important role in understanding the chemistry of the transition elements. There are many different types of magnetic properties. Only two magnetic properties we'll discuss, which are the paramagnetism is the property which appear in the ion or atoms or molecules that have unpaired electron in their orbitals. And diamagnetism, this is a property which appears in ion, atom or molecules which have all orbital paired electrons. Diamagnetic substances, they are the substances which repels the external magnetic field due to the pairing of all electrons. For example, we have give reason questions. Most of transition elements and their compounds are paramagnetic substances. This is due to the spinning of electrons in the d sublevel produces a magnetic field that's attracted to the external magnetic field. The magnetic moment in paramagnetic substances is directly proportional to the number of unpaired electrons. The magnetic moment of paramagnetic and diamagnetic substances is represented in the following table. For example, in y-axis we have the magnetic moment, and in x-axis we have the number of electrons in the 3d sublevels. This is for the first transition series. If we started from calcium, for example, which have 3d0, in this element we have no electrons in 3d. After that, with the scandium we have 1 electron. For titanium we have 2 electrons. Vanadium we have 3 electrons. Chromium we have 4 electrons. Manganese we have 5 electrons, which have the most magnetic moment in the first transition series. After that, the magnetic moment decreases again with the decreasing of number of single electron in 3D. So for example, we have 3d6 for iron, for example, for iron, which have only 4 unpaired electron. After that, cobalt 3, nickel 2, copper 1, and then zinc, which has no single electrons. All the 3d electrons are coupled. So the magnetic moment of the substance is a property which, when measured or estimated, it can indicate the number of unpaired electrons in the substance, and then determining the electronic configuration of these substances or its metal ion. As the number of unpaired electrons in D sublevel of the substance increases, the magnetic moment of this substance increases. In the light of the previous, magnetic moment could be estimated as follows. Paramagnetic substances, their magnetic moments ranges from 1 to 5, and diamagnetic moments with substances, their magnetic moments equal 0 because each of 2 unpaired electrons spins in the opposite direction due to the other. For example, classify the following substances to paramagnetic and diamagnetic. We have iron, nickel, copper, and zinc. So we're going to make the electronic configuration for the 4 elements. Zinc, for example, zinc atom. We have the electronic configuration argon 18, 4s2, 3d10, which means that the number of unpaired electron equals 0, and therefore it's a diamagnetic material. For copper, for example, copper ion have the electronic configuration argon 18, 4s0, 3d9, which had the number of unpaired electrons equal 1, and therefore this is a paramagnetic material. For nickel, ion positive 2, which had the electronic configuration argon 18, 4s0, 3d8, the number of unpaired electron equal 2, and so it's paramagnetic material. For iron, for example, iron positive 2, which is ferrous. If we make the electronic configuration, which is argon 18, 4s0, 3d6, the number of unpaired electron equal 4, and therefore this is a paramagnetic material also. What about the catalytic activity? Transition elements are considered as an ideal catalyst. This is due to the sharing of 4s and 3d electrons in the formation of the bonds between the reactant molecules and the atom of the surface of the metal, the catalyst, leading to the increasing of the concentration of reactants on the surface of the catalyst. This is number 1. Number 2, weakening of the bonds of the reactant, which decreases the activation energy of the reaction, and so the rate of the reaction increases. And this is appear in the following in the following graph. If we wrote the energies of reactants and product in y-axis and the reaction direction in x-axis, we find that by using the catalyst, we have low activation energy estimated. This is without catalyst, which with the violet color, and with the orange color have the high activation energy. This is due to the absence of catalyst. Let's get an example for a catalyst like manganese dioxide, which is used in the decomposition of hydrogen peroxide in the formation of water and oxygen, and this is an exothermic reaction. If we study the following table, we find that by using the manganese dioxide as a catalyst, the activation energy decreases. And without using the manganese dioxide as a catalyst, the activation energy is lower. After that, we have divided nickel, which is used in hydrogenation of oil to get dehydrated oils. After that, divided iron, which is used in the preparation of ammonia gas in industry by Haber-Pusch method. Nitrogen plus 3 hydrogens in presence of iron, 500 degrees Celsius, and 2000 atmospheric pressure, we get ammonia gas. After that, we have vanadium pentoxide, which is used in preparation of sulfuric acid in industry by Carson conduct method. We get sulfur dioxide gas, 2 moles of sulfur dioxide gas plus oxygen in the presence of vanadium pentoxide and 450 degrees Celsius. We get 2 moles of sulfur trioxide gas. And we get sulfur trioxide gas by adding water, we get sulfuric acid. After that, the colored ions. Why we have uh, the molecules of ion of first transition elements are colored. Colored substances absorb some photons from the visible light, and what an eye see is the sum of a mixture of remained colors, the reflected color, which is called complementary colors. If a substance absorbs all spectrum colors, so the substance appears black. If the substance doesn't absorb any color and reflect all color falls on it, it becomes white. And if a substance absorbs a certain color, so the substance appear with the complementary color. There are some absorbed colors there and there are complementary colors. For example, if the matter absorbs the orange color, the matter appears in blue. Excellent. And if the substance absorbs blue, it reflects orange. If the substance absorbs yellow, it reflects purple. And if the substance absorbs purple, it reflects yellow. If the substance absorbs red, it reflects greenish blue. If the substance absorbs greenish blue, it appears red. On uniting any color with the complementary color, white color is formed. So when green and red are unit, we get white light. If yellow and violet are unit, we get white color. If orange and blue are units, it becomes white color. So what is the relation between the colors of transition elements ion and their electronic configuration? Most of the compounds of transition elements and their aqueous solution are colored. That's as follows. For example, scandium is colorless because of the absence of 3D electrons. Titanium is red-blue. Vanadium is blue. Chromium is green. Manganese is purple. Manganese positive 2 is red. Ferric is yellow. Ferrous is green. Cobalt is red. Nickel positive 2 is green. Copper positive 2 is blue. And zinc positive 2 and copper positive 1 are colorless. From the previous table, we get the most of transition elements ion are colored. This is due to the partial filling of D sublevel D from 1 to 10. So the presence of unpaired electron in D sublevel. Chromium positive 3 compounds appears green because of the absorption of the energy of red photon, so the energy appears in complementary color, which is green. Zinc positive 2, copper positive 1 and scandium positive 3 are colorless because of the orbitals of 3D sublevel are empty in case of scandium positive 3 and completely filled in case of zinc positive 2 and copper positive 1. So they are not paired electron in these cases. This is lesson 2 and thank you.